Hi everyone, welcome to today's webinar. We're going to be tackling the topic of cable harvest planning, leveraging LiDAR data. My name is Erin, I'm your resident webinar host here at Softree, and thank you for joining us for our last webinar of 2024. Today's webinar is really going to focus on how to leverage LiDAR data for efficient cable harvest planning using our Terrain Tools Forestry software, which is also known as the module, the terrain module within RoadEng Forest Engineer. So our agenda for the next 45 minutes. To start, I am going to tackle some core concepts. We're going to talk a little bit about why you might want to use cable harvest planning for your operations. We'll talk a little bit about LiDAR data. We'll talk a little bit about what cable harvesting entails and some of the language that we use. And then I'm going to pass it over to Matt. Matt's on the call as well, and he's going to be giving us an in-software demonstration. Talk a little bit about how to import and model your LiDAR data, how to set up your cable harvesting configurations. And there's kind of two key areas that we need to set up in order to have it work. The first of which is our equipment, so defining what type of equipment we have. And then secondly, defining what type of logging setup we have. From there, he'll show you how to explore different areas for cable harvesting suitability, evaluate the payload, clearance, line tensions, as well as take a look at what happens if you change your logging configuration. We'll also briefly discuss some different ways that you can output or communicate and share your plans. So that's kind of our plan on a page for what the webinar is going to do. If you are new to our webinars, you are going to be muted for the entire duration of the webinar, but you can always expand that question section of your GoToWebinar panel, and there you can certainly type in any questions you'd like to ask, and we'll tackle those at the end. So that's our housekeeping. Let's get into it. So to start, kind of the reason why we're doing this webinar, obviously logging in steep terrain requires planning to be successful. And both the selection of that harvesting system or that logging system and the placement of the equipment on the terrain can have a pretty big influence on the success of the operation, whether that's looking at it through sort of a financial lens or even an environmental lens. And specifically in the case of cable yarding systems, proper positioning of the cable span can result in higher production and in lower costs, while hopefully minimizing some of the environmental damage that might occur. An improper positioning can result in some soil damage, possibly having equipment breakdowns, unsafe operations, and even potentially inoperable harvest units. So today, really, we're hopefully going to show you how you can leverage LiDAR to help you figure out and plan your logging operations in that steeper terrain. So a few different components of cable harvesting worth kind of mentioning as we talk about them. So we have we're going to call this the logging setup or the yarding system. And this refers to really the overall setup and the process that's being used to move the logs from the cutting area to the landing site. So there's lots of different types of systems, and we will show you how to work with those. But yeah, typically we can talk about like grapple yarding or high lead. But of course, the system that you select is really going to depend on your terrain as well as your logging requirements. So the next sort of component that we're going to be talking about throughout the webinar is the equipment. And here we're talking about the physical machine or structure that you're using that's typically equipped with winches and pulleys, and it's used to anchor the cables, lift the logs, and shown here in the image as we're highlighting it. This is the equipment. So we talk about the tower or the yarder. Of course, we've got cables. Cable harvesting feels like it'd be weird to not include them on our list. Different types of cables, and we'll talk about those as we evaluate and look at the different setups, as well as some of the outputs that you can get from cable harvesting, so the different tensions on the lines. And then finally, the last piece, we do have a carriage. So a carriage, typically that device that travels along the skyline, and it's used to lift and transport the logs. So those are some of the components. We'll discuss those throughout our webinar today, and we'll talk a little bit about how to get it set up in our system. Okay, pivoting kind of to the other side of it, which is the LiDAR data. So hopefully none of this is new to anyone here on the call, but LiDAR has really been, a game changer in forestry. It's high resolution survey data, and it has been steadily growing in popularity as well as, I'm going to say, availability across all the different industries that Softtree works with. So we are obviously wanting to show you how to leverage it. And I'll show you on the next slide here a few different sources. There's so much LiDAR data that has become publicly available as governments and organizations look to make it accessible. So if you already have it, awesome. If you don't have it, there's always a good chance that some of your area is covered by it. But a couple quick notes on LiDAR. So it is typically packaged in what we call tiles. And the size of those tiles, especially if you have to use multiple of them, can mean that LiDAR data sets are enormous. And so when working with these super high resolution survey data sets, it's really important to make sure you are managing and controlling how many points are included. And hopefully Matt's got this on his agenda for today, but the idea of thinning your data is so important in keeping that LiDAR data set to be a manageable size. Rule of thumb, when working inside of our software, we try to keep it, your modeled points to under 10 million. It sounds like a lot, but we've seen LiDAR data sets up in the gigabytes of size, which ends up being, I don't know, about 100 million points. So you're going to have a whole bunch of slowdowns if you're working with one of these extremely large sets. So yeah, making sure you're leveraging those thinning tools. So LiDAR, great type of survey data, really awesome for working with cable harvesting. And as I mentioned, there's a whole bunch of publicly available LiDAR sources. And we've actually made a compilation of these up on our Softtree website. I think it's like softtree.com/free-LiDAR. You can get links to these, but so much data is becoming available and is literally growing every single day. And there's a huge amount of benefits for leveraging LiDAR for your cable harvest planning. First of all, low cost, possibly free. It's a very, very efficient survey method for getting really large areas. And it is fairly accurate. Of course, the resolution of each data set is going to vary, but it tends to be quite a bit more accurate than some of the more conventional survey data methods, whether you're going out there and collecting P lines or total stations. It gives you a fair bit of accuracy with a huge amount of land coverage. Which is that third point. So it covers a large area. And this now allows you to compare that multiple different harvesting locations and configurations and being able to do so from the office, which is really, really powerful. Okay, final couple points for me, and then I'm going to pass it over to Matt. But just a few reasons why you might want to plan your cable harvesting operations and some things you can do in the software. So using the Terrain module, you are able to explore areas for deflection. And we've got a great tool in the software called D-Line Explore Mode. So you can look at sort of a radial burst and explore multiple areas all at the same time. It's going to give you the ability to evaluate different equipment configurations, logging configurations for suitability on your terrain. You can, of course, analyze the payload, clearance, and line tensions, plot those different carriage positions given midspan deflection or the third point method. And then you can also communicate these plans. So when it goes to actually implementing them out in the field, you're able to communicate them through the creation of an output sheet, even look at exporting to something like Avenza or GPS points. You've got a whole bunch of options here when it comes to outputting. So inside of the software, we're going to follow a little bit of a workflow. And I guess it wouldn't be a webinar without a little bit of a workflow side. So we're going to start with the ground profile. This is the topo, the LiDAR service. We can talk about, create it, import it, generate the TIN. And from there, we're going to go ahead and configure our logging setup and our equipment. So they are two separate dialogues. You're going to have to input them in, but the logging systems, that's the type of cable configuration you're working with, the different cable working tensions, the carriage weight, those types of items. And it operates almost like a template does, a cross-section template if you're familiar with them in the location module. So we can set that up and then we can save it and then we can reuse it again and again if we want, or share it to a colleague, same kind of idea. From there, we can explore, use the explore mode. So this is a radial burst that allows us to explore multiple deflection lines simultaneously to figure out what areas are the most suitable based on our equipment and our logging setup that we've defined. We can show you how to select and modify the D lines of interest, so the deflection lines of interest, do a little bit of a payload analysis, and then we'll talk a little bit about output. So that's enough for me with a very boring PowerPoint. Let's get into the software. And from here, I'm going to pass it over to Matt. And we'll go into the software and take a look at that workflow. Matt, over to you.
Excellent. All right, so I'm going to do my part in two phases. So the first part, I'm just going to give a quick overview, and then we're going to back up and kind of look at it in kind of the incremental levels and unpack more of what we do here fairly quickly. So again, to start, I'm going to intentionally go relatively fast, but then I'll come back and talk about it slower. So I'm going to bring in my LiDAR data. So I'm opening Terrain, I'm going to bring in my LiDAR data. In this case, I'm using DEM data. Brought it in, we're going to turn that into a surface. We've got a surface. We can see that surface in a 3D view. And if we want to do our D-line analysis, well, we totally can. We can come over here. And as Aaron said, we can do our D-line Explorer, where we can do a bunch of D-lines all at once. So I'm going to use this tool. We're going to tell it how many arrays to extend out. We can see what we could get from that particular spot. And if we're happy with it, we can click OK. We can say, well, what does that particular D-line look like? We can see what clearance we're dealing with. And we've done that for 24 possible cable configurations, all off of that same landing. We've got a bunch of work done. So that is where are we going? And let's just start from scratch and unpack those individual elements a bit more. So we're going to work in Terrain. So we're opening up a new instance of Terrain. I'm going to bring in my LiDAR data. So LiDAR data is commonly a variety of different formats, but the two most common are going to be the LAS or LAZ for the raw point cloud data, or a TIFF with the DEM data. So we're going to bring that TIFF in. Here, the TIFF can either be an image or it can be a DEM. So we're going to select that it's a DEM. We can do our thinning if we need to do some thinning on import, but I'll do my thinning afterwards, and we'll kind of talk about what's going on. So we've brought in our data, and to start, if I zoom in here, this big magenta blob is actually about 1.5. So I'm going to click off to the side, and it's going to deselect those 1.5 million points, and they all appear to disappear, but they're actually hidden. They're still in our model. And we want to turn those points into a surface. So we could go up here and we could generate a surface. Now, as Aaron mentioned, if you have really large data sets that are, say, 100 million points instead of 1.5 million points, it's not a problem. Just before you build that surface, you're probably going to want to isolate it down to an area of interest. And for that, you could have your own polygon. It could be a shapefile or something like that, or you could just draw a feature. So I'm going to draw a box. I'm going to turn this diagonal into a box. So this little inside box that I've called AOI is going to be where I want to keep the data. And then anywhere outside of that, I could either dumb down the resolution or I could remove all the points. So I'm going to dumb down the resolution. So I'm going to go simplify. So inside of my AOI polygon, I'm going to leave the full resolution, but outside of that, I'm going to go down to a 30-meter grid spacing. We'll hit OK. We'll hit OK. And it tells us, well, we went from 1.5 million points down to 1.1 million points. And just to note, this is a fairly small example, but you typically use this again if you had more like 100 million points rather than 1.5. And if we hit Control A here, we can see what we're dealing with. Inside that polygon, I've got this very dense point set. And then outside of it, I've got these much sparser points. So that is thinning. We're still going to turn it into a surface. So we're going to click Generate. We can create our contours at the same time. We'll hit OK. I'm going to click the 3D view. So this little icon down here. We're going to tile those views side by side. And my 3D is blank right now, but we're going to click Zoom to extents and we can see we're dealing with things. And if we go here, we can see that difference from the full resolution LiDAR data to the data that we've thinned. Now, for an entirely optional part, but I would like a little added context of what is going on here. So I'm going to select a feature. So I've got my outer bounding box selected. I've import, and now I can connect to web map tile services that give me my orthos right at the click of a button. So we're going to click and drag. We're going to hit save. And we're downloading that imagery. So again, this part is totally not a requirement in the core workflow, but it's always nice to see what you're dealing with. And we're going to just save this here. And there we are. So far in our workflow, we've brought in LiDAR data, we've turned it into a surface, we've added an image, and now we're set to start doing some cable analysis. And so with that, we're going to click our cable analysis tab. We've already set things up and have it the way you like. You could jump right in and doing individual D-lines or D-line explores to figure out where you can log in your block from whatever landings you have proposed. But my goal here is to provide the explanation. So when we did this last, we have these different logging systems that we can pull from. So if you don't have a logging system listed that represents the equipment that you're planning to use, well, it's not very useful. So we're going to add in our own equipment here that represents what we'd like to deal with. So this list is populated from our logging systems. And if we click add, well, one thing that we need to know is the equipment that you're using. So the logging system controls kind of the configuration that you're going to set up. So are you using a running skyline with a grapple or a running skyline with butt rigging? Whereas the equipment button is going to really control, well, what's that main piece of equipment that you have with your winch attached to. So I'm going to start by defining my equipment. So I'm coming in here. I am going to, well, let's add in some specs for a harvest line. So we're going to click add, we're going to give it a name. And we're going to populate our specs. Now with this, usually if you're doing this, and if you want to use kind of all the fancy stuff like calculating load, find out the equipment specs for the the piece that you're dealing with. So here, if I go onto their website, I can see all the pertinent information that interests me, except for some wire rope stuff, but we'll talk about that in a second. So max length for this piece, our skyline is, and actually I think this is a 2-inch system. So one of these is just kind of null, but yeah, we'll fill this out. So my main line, max length 500 meters. My haul back 1,000 meters. My max working tension. So I mentioned that the wire rope plays into part of this. So it might be that you're just interested in the max pulling capacity of your yarder. But oftentimes you'll also consider, well, what size wire rope am I using? What's the strength of that? And then usually folks will factor that down a bit to have a max safe working load rather than just a max capacity. So I'm going to throw in some values here. So let's go 702.9. Of course, you can change the units to match whatever you'd like. And I'm going to just use this across because it's the same wire rope for both drums. We'll go, so this is the weight per length of our cable, and spire height's a big one. So with this, even if you're just using simple 3-point deflection, in which case this other stuff won't really matter, but for spire height it will. So I want to go with 11.5 here. So we've got this new piece of equipment added. We can hit save as default if we wanted to use this in the future. And sure, I don't mind having that in my list. So, and again, just to reiterate, if we go in here, we don't have that harvest line equipment that we just built because we don't have the logging system defined yet. So going into the logging system, we're going to add in our line grapple. So for this logging system that we're using, we're going to use that piece of equipment that we've set up. The configuration that we're going to run with the running skyline configuration. And we'll say that our grapple is 1910. We've got this logging system defined, and we could have multiple systems for that harvest line if we'd like, but in this case, I just want the one, and I'll hit save as default. So the next time I open the software, it's there, and I don't have to populate it. So with this, everyone saw me click the enable button where I shot out 24 arrays in every direction from my proposed landing. Instead, and to provide a little bit more context, I'm not going to use that. I'm going to create a new D line. So I'm just gone to home, click new feature. I'm going to say this feature is called D line. And the important thing that we draped line. And by that, I mean, as we draw our line, it's going to show the ground profile underneath it. So for that, we're going to turn on, elevations off, we're going to display everything else. So we'll hit mouse, we'll click here, and let's see how far I can log out this way. And we'll see that that line is now clamped to the ground because it's draped. Click profile, we can see what that ground is doing now. Now, I'm just going to move this around a bit. One really nice thing about this, move this, it's going to update dynamically. So if I wanted to kind of say my yarder is going to sit here and maybe we're walking a mobile backspar across that trail, well, we could just use a single D line and check it by moving things around manually. And of course, if we're doing that, we want to apply our piece of equipment to the the profile we're looking at. So for that, we're going back up to the top, and we'll click New. And just before I click New, so where we're at, and I know I'm talking lots, but trying to give the explanation. We've got our surface, we've got our equipment defined, we've drawn a line, and we want to do our D-line analysis on that particular line. So to do the D-line analysis on that particular line, while it's selected, we click New. And then we've got this dialog, which is very similar to this one for content, but we're going to select our log system, which is great. We've got our head spar location set at station 0. And then we've got our haul back block station. And we can hit OK, what we're dealing with. And we're getting all kinds of lift right to the back end. Now, we could go in here and move this around, and we can see, well, we're losing some deflection there. We can see it showing up in red now where we're running ground lead. And if we wanted to make adjustments here, well, we could. So we can just, with that still selected, click Edit, and maybe we wanted to say, well, we're running a mobile back spar across the back of that. Maybe we've got some extra lift for our haul back block. So I can click that. And now we can see, well, we're getting our lift. So pretty straightforward, dynamic, kind of minimal parameters to set. But we can look at the problem in more detail. So this is running with, well, set up to be the way I'd like, but we don't have to just use this minimum deflection given load. So for that, what we're calculating is, well, we've got those equipment parameters that we've specified with the unit weights of our well, system components. We've also told the software that our P size is going to max out at 10,000 pounds. So what this graphic is representing is if we're maxing out the tension on our machine, well, what would be the path that that carriage follows? So if we went crazy here and put in a much bigger number, well, it's not showing up because we're exceeding those limits. And we could turn on some sub windows to show us the errors. Let's go back here though, and let's go with 15,000 pounds. So here we can see we've got a bit of lead again at the back end, but since we're dealing with such a larger payload, our carriage path is much lower. So we can use that, and we can kind of iteratively explore different configurations. If we had really large logs and wanted to consider, well, what are we giving the buckers for specs to split those up? And so aside from just considering what our piece size is, maybe it was, well, what happens if we use a different piece of equipment? So instead of that harvest line, what happens if we go with a Logger Champ 650? Something that I've already set up. And we can see, well, it's same load. We've got much better clicks just given the max tension that we have specified for that machine. Yeah, I'm going to go back to what we had. Now, aside from just that one calculation method, another kind of calculation method that ignores all the tensions and all the kind of the complexity of the problem, but still gets used a fair amount as well. I don't consider all that stuff. I just want to consider my tower height and assume 3-point deflection with an 8%, or sorry, split the length into thirds and apply an 8% sag or whatever number we like. We can click that, and now boom, we've got an approximation of things. Another method that we could go with is max flying load given clearance. And we're going to say, well, I want to keep the carriage off the ground by, let's say, 4 meters. We'll hit OK. We'll hit OK. And this graphic isn't really all that interesting at a glance. So we can see the carriage path that we're looking at is very closely tracking the ground. If we increase the number of slices, well, it'll sample more frequently along that, and it really is just following the ground. So with that, the reason you might use that calculation method is, well, knowing where the ground is pretty obvious. The big question is, well, what size load can I run and maintain that clearance? So I'm going to add in, we'll go tensions, load, and sure, we'll include that as well. So here I can see that in order to maintain that 4-meter offset, I'm going to have to dynamically adjust the tensions of my haul back and main line. The length of cable load is going to change, and then the load that I'm able to pick up anywhere along that profile changes as well. And we can see as we get further out to the back end, in order to maintain that clearance, well, we have to take smaller pieces. And if we want to see that tabularly, we can. We can just populate this based off the same parameters. So yeah, when we're out by station 268, we can only lift 3,000 pounds. Now, the last kind of hit, got minimum deflection given load is what we started with. We've got max flying load given clearance. And then, well, we could also just look at if we had a fixed skyline situation where we're not dynamically changing the length of that skyline, we could calculate what we're dealing with for clearances and forces there. So that is kind of, well, a lot of explanation for what's going on. But just to reiterate kind of where we started, it's useful to know all this stuff, but it's really something that you can do in a matter of minutes as you get going. And so here, if we want to, instead of doing that single D line, we're going to do a bunch of them. So same idea. We have access to what calculation specs we're using, choose what logging system we're using. We've got a couple extra parameters in the D-line explore options. Here I'm going to say, well, our max length is meters. I can tell it how many radial lines we want to shoot out. So I'll go 12 this time. And we could add that tails haulback block height in here. We'll go over here, like that, and oh, and that would be why. And so I'm using a small indented. All right. And I could see that it wasn't gonna capture what I wanted to capture. This, I'll hit accept. We can see we're, well, extending out from that landing location. We can click whichever one of these we'd like. And now I've clicked this. I'm probably going to want to change the profile to match the selected feature. So I'm turning auto on. There and we can see, just as we'd expect based off the color coding, we're running ground lead out there. We can check that out. And if we'd like, we can say, well, maybe we can make things a little better. If we move that over, nope, that's not any better. And well, here we're getting our minutes. And if we want to tweak that, well, there's still features. We can still click edit and we can make adjustments to those individual lines. Yeah, so with this, if we did our analysis, maybe we do a few different landing locations, looking at different block locations. Well, we could delineate our own potential block boundary. So I'll just hit new feature, and we could go in here and we could start digitizing that if we were interested in laying things out. And we can change the line work. And there we are. Now, if we point where, well, I want to take this and use it as a tool to communicate to other people, we'll do that, and we can do that with our multi-plot. So for this, I can click this little icon here, and I can add in a bunch of different subviews. So I can build out from scratch. There's our profile. Or it could be that instead, I have something already built I'd like to use as my starting point. So I'll click retrieve. I happen to have one saved out here. And there we are. So we can really automate that process of putting together your documentation. And with that, I think I've covered the bulk of what I was hoping to cover, and we can open it up for some questions.
Awesome.
I'll hand it back there.
I did have one slide I wanted to share, kind of just recapping some of those output options that Matt just mentioned, and in particular showing you kind of what having multiple deflection lines on a page might look like. So again, when it comes to sharing, 4 big options: multi-plot, being able to share the cable data tables. You can copy those to the clipboard and share them. You can export through to Avenza, and then we've got a whole bunch of other export formats, whether it's sending it to Google Earth, creating a CSV, DWG, or even LandXML. So lots of different ways you can share your cable harvesting plan. Then a quick reminder, if you want to ask us some questions, we've got, about 8 minutes left in the webinar, so we can definitely tackle some. You can type them into your GoToWebinar panel. There is a question section. All question askers do remain anonymous, and there is literally no such thing as a bad question. So feel free to expand it. You can type your question in there. And then while you are doing some typing, I did just want to highlight our 2025 webinar calendar literally got posted this morning, and I'm really excited about some of the topics. I feel like we've got a few in here that we've never really presented before. In particular, and very relevant to the group on this phone call or on this webinar, we're going to be doing a special webinar on road design in steep terrain and talking about tools for that type of challenging landscape. So that's February 27th, 4th one on the list here. You can check out the full calendar. I think we're almost till the end of March up at softtree.com/webinars. So be sure to check it out. Lots of really great new topics that we've never done before. And the other one, managing water with confidence, talking about culverts, ditches, and drainage and road end. So new topics up on the website. Check it out. And with that, let's move into questions. And Matt, I think you're going to want to have your screen, so I'm going to make you the presenter again. As we go through this. So the first question is not really a question, it's a comment, and it's a great one. So up on that free LiDAR we talked about, public sources. If you're in British Columbia, one of our webinar attendees did want to reiterate the awesomeness of all the publicly available LiDAR that's available on the LiDAR BC portal. So that is definitely, a really great resource if you're in British Columbia. And if you're not in British Columbia, again, lots of other sources. We tried to summarize those on our website. Okay, it looks like Matt's going to bring it up. It is a really great website, great resource. So first question, is there an option for adding an intermediate support?
All right, that one, I guess the gist of it is not directly, or not one that fully yeah, you can do it by breaking the problem up into two. So it'll eliminate accounting for some friction and whatnot at that intermediate sport. But you could essentially run your beeline from the start station out to another point. So here I've got my beeline selected. I could say I want to run that out to, say, station 200, and that intermediate sport could be at like, I don't know, 10 meters. We can go with that. And then we could copy, paste, and we could, well, go from 200 to the end. And here we'd want to change to have an intermediate system that represented that intermediate sport capacities and whatnot as your yarding system. Or you could kind of cheat and go with the 3-point deflection method. So not directly, but there is a workflow for it, and that is detailed in our training as well for this, which has a self-paced course that you can run through that will include that information.
Awesome. Okay, next question. It says, how do I output the orange boundary line or the orange line boundary adjustments to communicate with the contractors, or how to import it into our GIS system?
Yeah, so for that one, and let's just, so one, you could go with having it indicated on our drawing here in the multi-plot. And you could even go file, save as, and we could save that out as being an Avenza file, which gives you that plan view portion as a georeference file that they can take to the field, which is always nice. But if it's easier to export it out and go into another environment like ARC or something like that, where you're tracking this information, using it as a database, you totally can do that as well. So here, file, save as, and we can change our extension to a bunch of different common formats. So we could export it out as a KMZ, or we could export it out as a shape file, would be I guess the two most common to go into that environment. So let's call this BDY for boundary. When I do that, now here, I just drew a line rather than having a proper polygon. So it's a polyline that I want to go with, and I can just select the selected feature only. We can see, well, there's only one selected feature, and we can export that out as a shape, and then you can take that over to your mappers.
Awesome. Oh, sorry, did you have more, Matt?
I was just going to say, hopefully that answers your question, but yeah, pretty painless and lots of flexibility if you want to do something a different way.
Okay, now this one, I think it's going to be a fun one to answer out loud, totally verbal. But has there been any development towards integrating this feature into the alignment optimization tool to look at logging system access viability?
Yeah, so I guess not directly linked as being in like the same interface, but I mean, that's the two tools kind of are a few clicks apiece, and most folks for that, figuring out your access side of things, they'll start in the grain side, figure out where they might want to try and get their landings located. If it's kind of that greenfield example, where do we want to get to? So, and then in terms of the path explorer tool, which is that kind of, I want to go from here to there. Well, your point A is wherever you're branching off your existing road. Point B is, well, that landing location that you want to get to, that you've confirmed has good deflection that is worthwhile to try to get to. And then in a matter of a few seconds, you can determine feasibility, put some cost to it, and even kick it ahead to actually using your whole drawings and seeing how much dirt you're moving there.
Awesome.
Hopefully.
Let's do one last question. I know we're right at the brink of time, but let's do one more, which is how do we save and set up a multi-plot page template? Be great for consistency between staff. And while Matt kind of gets that question organized, I should mention multi-plot in Terrain is handled very differently than multi-plot in location. So if you are a user of our full RoadEng software, how we have got it set up in location is a little bit different. We did some huge improvements to that part of the software back in version 8 or 9. And those improvements, we never actually implemented them in Terrain. So with that, Matt, do you want to maybe highlight how we would set up multi-plot page templates inside of Terrain?
Yeah, okay. So for this, I went back to my normal screen layout, which is my default. So all the moving windows around that I've done previously is not showing. So starting right from square one, as Aaron said, the multi-plot in Terrain is quite a bit different than what it is in location. We're going to have that multi-plot layout tied to our screen layout. So with that, when we start building out our template that we want to use in the future, well, we're going to pop open the multi-plot view. I'm going to just tile my views side by side. And here we can go to our multi-plot and we can click new subview. And it's only giving me the option to add in my plan and my 3D. And that just happens to be the only views that I have open. So if we want to, I'm going to turn a grid on just so I can kind of make things line up a little easier. I can go multi-plot, new plan, and we'll push this over here. And I'd probably want to add I don't know, maybe a legend and some text box to give project details. So we'll scoot this down a bit. I'll do my text box and I'll say example single D-line. And we'll center that. And then, well, it's not giving me the option yet to have my profile. So I'm going to want to have a screen that has a profile existing in it. We might want multiple if we were looking at multiple. But I'm going to click that profile button so we can see what we're dealing with here. And we want to configure it. Well, let's go scale 2500 and 2500. Now my scale is locked. I also probably want the same scale in my plan. I'll look my scale for that. And now that I've got that profile existing, we can click multi-plot, view sub, profile, and away we go. So we've set up a multi-plot from scratch. And then the big thing, just so we can use it in the future, and we don't have to do all that clicking around next time, is view, screen layout, hit save, and you can save these ILT files, which are your screen layout file, right in the default directory, so they're easy to find if you're using it as your standard template, or you could put it in a project folder if you want to keep that with your project documentation. Put it up, and then just as I did there previously with the other screen load, just switch over to it you'd like. So hopefully that answers that question. Let us know if it doesn't.
Very good. Well, thank you everyone for joining us again. Last webinar of 2024. Hopefully you can have some time to take a look at the upcoming schedule that we just released today, 2025. And with that, wishing everyone a very merry upcoming festive season. And we look forward to seeing you again in the new year. Thanks, everybody.